Okay, this another supplementary video where we try to explain to you how the conversion from infix to postfix was done using a stack. You know what a stack already is, we already discussed it. Therefore, you can push elements onto the stack and pop elements of the stack. You can look at the top of the stack, you can check whether the stack is empty. So, basically that the stack is what is called a last in first out ADT. So, what it means is that when we are pushing elements onto the stack, if this is a stack here, then if let us say I push these elements, we already saw this example 4 and 5, then suppose this is the topmost position of the stack, I push this element here, 2 here and so on. But if I now pop, I can only pop from here, therefore, the elements, if I keep continuously popping, the elements will be popped in reverse order as we saw in the example. Okay. So, basically the operation of the stack is what is called a last in first out. And in the class, when I did this lecture, I told you how we can use this to convert an infixed expression to postfix expression. What I am going to do now is, I am going to give you some C++ code which does exactly that. What did we say? Look at the input. When an operand is read, place it immediately in the output. When an operator is read, what did we do? If the top of the stack has higher precedence than the operator, then you pop all the operators of the stack until top of stack has lower precedence. Then you stack the current operator. When you see a left bracket, you place it on the stack. When a right bracket is read, you pop all the elements until the left bracket, pop the left bracket, then you pop all the elements of the stack, and you keep repeating this until the end of the input. This is what we saw. So, now what I am going to do is, I am going to show this using a program. Okay. Let us look at this. This program is in fact even more complicated. What we have done is, we have also permitted what is called this program that we have implemented is a little more complex, and let us go through this over here. So, here is the usual implementation of the stack. Now, I am using an array implementation of the stack, does not matter, we can use array or linked list as we already saw. We already saw a program which uses both and exactly runs the same way. What I have done is, here is something which will give me the priority of a given. What is priority now? The precedence of a particular operator. Remember, in scientific calculators, when you say 4 plus 5 star plus 3, then this 5 star C will be computed first, and this will be 4 plus 30 plus 3. And of course, you do the evaluation of the expression from left to right. So, we have to ensure that. Why are we converting this into a postfix expression? Because the postfix expression is a very convenient way of taking care of precedences. For example, if I have something like this, 4 plus 5 star 6 plus 3, when I convert it to postfix, this will become 4, 5, 6 star plus and 3 plus. So, what does it mean now? If I want to evaluate this expression, I keep moving from left. This is the assignment that has been given to you. As soon as I come across a star, I can again use a stack for that. I pop off the topmost 2 elements on the stack and perform the evaluation. So, when you look at this expression, for example, unless you know the precedence of plus and star, the relative precedences between plus and star, you do not know which has to be evaluated first. If plus is having higher precedence, this has to be evaluated first, this has to be evaluated first, and then star. Alternatively, if here in the normal understanding of ours, plus is having lower precedence. Okay. So, this has to be implemented like this. But as soon as we convert to a postfix expression, there is absolutely no ambiguity. I am going to give you one more example. Okay. The another important point about postfix expressions is that even if the associativity of the operator, it can be left or right. For example, we know that when you look at x power y power z, it does not, it is actually x power y power z. Okay? It goes like this. This is how it works. All right. So, this is called associating to the right. Okay. So, when we are looking at exponentiation, for example, now if I have a number 4 divided by 2 power 3 power 2, this is actually 4 divided by 2 power 3 power 2, okay, and not 4 divided by 2 power 3 power 2. Okay. This is an important thing that we need to understand. Such operators are what we call to be right associative. They associate to the right. So, in this example that I am talking about, there are, and not only that, exponentiation also has higher priority than multiplication. It is done first. So, there are two things that we are looking at. One is the precedence of the operator. So, I write one simple function which will look at the operator which is of some particular element type, and then it will tell us whether it is, you know, the precedence of that particular operator, for example. We have also put bracket because bracket is also going on to the stack, as we saw in the example in the class. Going back to this example in the class, what did we do? If you remember, right, this is what we did. Let us take that example now, and let us say this was the expression. Remember, we also put the bracket onto the stack. So, this was the expression that was given, a plus b star c plus d plus bracket d plus e slash f. What do we do? If there is an operand, we are pushing it out to the output. There is an operator, push it onto the stack. Then you have a star here. Then what do? You also again operand, move it to the output, star, push it onto the stack, operand, push it to the output. Then what happens? The next plus comes. Then what do? Once a new operator comes, here we did not do anything because the star operator has higher precedence than that of plus. So, we just put it on top of it. When a new operator comes, I look at all the operators that are there on the stack. So, I look at the topmost guy. So, clearly star has higher precedence than plus, therefore, we pop it off. And then we look at next what is there on the top of the stack. You have plus which is on top of stack, and clearly plus and this have the same precedence, and since the operator is what we call left associative, we push this plus out. Otherwise, we will not push it out as before the exponentiation operation, which is given in this piece of supplementary code. Okay. And then when a bracket comes, you put the bracket and then onto the stack, and then you do the rest of the operations in the usual way. And then what do? Once you come across a right bracket, you have to pop everything until the right bracket. Okay. We saw this in the course. All right. So, now what we are going to do is, so here is a function which will return back the priority of a given operator. Okay. I have also put exponentiation. Then here is another function which I have added, because so far when we look at plus and minus and multiplication and division, they always associate to the left. What I mean by this is, if I say a minus b minus c, it is a minus b minus c rather than a minus b minus c. This means association to the left, and this means association to the right. As I said, only exponentiation is different. It associates to the right, okay, as we saw some time back. All right. So, basically what we are saying is, when you are doing this over here, it is 2 to the power of 3 to the power of 2. Okay. That is the fundamental difference. So, we also included that operation just to make it a little more complicated. Okay. Then what does it do here now? Then we are returning just for some bookkeeping, for example, if this what does it do? This one determines the associativity. So, in associativity, it is returning either 0 or 1. And then we are looking at the kind of the operator. If it is not an operator, for example, then we are returning a 0 over here. And now finally, let us look at a convert to infix to postfix. So, this is what this convert infix to postfix is, a regular function like how you would write in C or in C++. What am I doing? Within this convert infix to postfix, we are using a stack. Okay. So, what are we doing now? All right. So, we create a empty stack. After creating the empty stack, you have basically what is the, so what is it now? The postfix, the infix expression is given in this strin. We already saw the benefit of, if this is the infix expression, this is going to be the postfix expression. The advantage of the postfix expression is you don't have to worry about brackets, you don't have to worry about precedence. As soon as you see an operator, you move from left here. As soon as you see an operator, you take the most two recent guys and perform the operation, okay, depending upon whatever your that's all there is to it in terms of the infix to postfix. You don't have to worry about associativity, you don't have to worry about the precedence of the operators, okay. That is the fundamental property of it. So what are we doing over here now? We check whether it is operator, because the string is an expression that is given, and then what are we doing? If the priority of the top of the stack equals to the priority of the input, and if the associativity is also the same, then what are we doing? We are simply popping all the elements from the stack. Otherwise, what are we doing now? That is, we are starting if the operator is this, okay. Then what we do is, if check if what are we going to do now? We need to pop elements from the top of the stack until the stack has a priority which is less than or equal to the input, or the stack is empty, okay. Then we check, of course, whether it is left associative or right associative. That is not so important for you, okay. We ensure when you do right associativity, you have to ensure that the element on the stack has a priority which is greater, otherwise not equal to. That is the fundamental difference, okay. All right. So when the operators are left associative, you keep on popping all the elements, okay. This is essentially the piece of code that we are looking at for infix to postfix conversion, all right. So basically the idea is that what I want to impress upon you, although this function looks rather long, is that we have an input string, and then what are we doing? This input string is processed, and that is, we are going through this input string from left to right. So this is the input string that is given. Go through left to right. If it is, then what do? You look at this. As soon as you see an element, just return that. If it is not an operator, then you just simply push it to the output. And on the other hand, if it is an operand, for example, if it is an operator, then you check if it has the same priority as the input, and is it left associative or is it right associative, and appropriately you decide whether you will pop the operators off the stack or not, okay. And if on the other hand, if it is an operand, you simply push the operand directly to the output, okay. That is the fundamental activity that we are doing in this particular function. But what I want you to notice this here, this is where we are doing this. Just it is an operand, so I do not have to put it onto the stack. So I simply copy it to the output string. What is interesting about this program is that, notice that this is, again I repeat, this is a normal function, looks like a normal function in C, but within that it is using a stack. Stack is an abstract data type, and we are using the operations that are permitted on the stack to do whatever we want, and then we finally output the particular string. So let us simply run this particular program and see what it gives you as output. Okay. So what am I doing here now? I have this infix to postfix program. Okay. I am just going to run this particular function. So it is asking me for the input string. Let me give a plus b star c plus d slash f whatever. So what do we expect now? Now basically there is a bracket there, therefore it has to output the elements on the bracket, and the plus within the bracket should be performed first. So we do this, and this gives us A, B, C, D, F. Notice that means the first operation that is going to be performed is D slash F, and then it performs this plus, and then the star, and finally the plus. So now one of the assignment problems is to perform postfix evaluation using the stack. So what's going to happen now? Earlier you had the element type on the stack, which consisted of characters which corresponded to your operators. Now the element type on the stack will be integer type. So what are we doing now? You are given a string. So what you have to do is, given a string, you have to perform assume that you are given a postfix string and you are supposed to evaluate the postfix string. I think that's basically the idea. So you can again use a stack here, as is obvious, because D and F are operands here. So that means I just keep on pushing all the elements onto the stack. So what happens till I come across an operator. Then when I come across an operator, what do? So on my elements on the stack, I have A, B, C, D, F. I take off the topmost two elements, perform the operation, okay, and put it back on the stack. Then I see a plus. Then what do? I take off the topmost two operands, push it onto the stack. Let's look at with an example over here. So what is it that we are saying? If this is the stack, I push A, B. Remember, this is a postfix expression. That means we are giving A, B, C, D, F slash plus star and plus, right? That's what we have as the expression, postfix expression. So what are we doing now? Onto the stack now, if this is our stack, we simply push all the elements. That means I am reading this postfix expression from left to right. I push it onto the stack, D, F. Now what happens? I am seeing an operator. So as soon as I see an operator, I pop these two elements from the stack. I perform, because it's from left to right, I am performing D slash F. I perform D slash F, then what do? I push it back onto the stack, D slash F. Now next, what do I see? I see another operator plus. When I see another operator plus, what do? I pop these two elements, and what do? I have C plus, plus is the operator. So P plus D slash F is performed. Again you push it onto the stack. Next you see a star. When you see a star, what are we doing now? Again we perform B star, because these are the C plus D slash F is there, and B star. Therefore this is multiplied with this content. Again you push it back onto the stack. So that means what are we doing now? We have B plus C plus B star C plus D slash F, push it onto the stack, and then you have A, you have a minus or a plus, it's a plus over there, sorry. So you have plus here, and then you do A plus B star C plus D slash F, and the stack becomes empty. There are no more, notice that the input string is over, and you just simply output the stack is also empty, because what happens? I remove these two elements, and then I am simply putting the result. Therefore, the result consists of corresponds to the evaluation of the expression. Okay? So this is exactly what you are expected to do on the assignment. What I have shown you here is infix to postfix conversion using the stack over here. Okay? So what did we do? We are just giving an input string here, and then given that this is the input string, it converts us to the postfix string over here. All right. So this is primarily your task on the second part of the assignment. All right. So I hope by now you have understood two important things. What are the two important things that we saw? In this lecture, we saw that you can use a stack to perform infix to postfix conversion, and if you remember right, notice that over here, this function infix to postfix, which is there in the code over here, notice this over here. So this convert infix to postfix is something that we have not yet seen before. Convert infix to postfix is another function, and what does it do? It uses a stack internally. A stack has already been defined, okay? and the element type that goes onto the stack is what the user specifies, and then he is simply using the stack like you know that plus will, if I give two floating point numbers, plus will add the two floating point numbers. Here a stack will push elements onto the stack, pop elements from the stack. It's a last in first out ADT, and that's precisely the property of the ADT, that the user, who is the user here, is the convert infix to postfix function which is doing this particular operation. All right. And then notice I have another main program on top of it, where what do? You have defined some particular expression length, that is the user's idea. So he gives a particular expression length, inputs the string is read, and then what does he do? He again creates another, so given the length of the string, it creates a new output string and then passes string in and string out. Notice that this whole main program is completely harmless. The main program does not know that convert infix to postfix is actually using a stack inside. Okay? So this is something that is very important to understand. So we have seen primarily two different characteristics over here. We have seen the stack ADT implemented with a particular element type, and we have seen that convert infix to postfix, for example, is actually using the stack ADT inside. The main program is not aware of it. Okay? So this is the important takeaway, and in your assignment, for example, in postfix evaluation, what are you expected to do is not a stack of operators, it's a stack of operands. Okay? That was given to you. So given that, what they have done is they use the in that particular assignment, for example, the stack has been implemented. The implementation may not be exactly the way I have done it in the course, it can be a little bit different, okay? But it still has the pop, the top and the empty operations. That's kind of irrelevant to you how it's been implemented. Using that stack, how can you implement postfix evaluation? That is the question that is asked. And we see now what is it that we have to do. As you see an operand, every operand is pushed onto the stack, and then as soon as you see an operator, you perform the evaluation. Notice the fundamental difference between convert infix to postfix and postfix evaluation. In convert infix to postfix, what are we doing? We are pushing the operators onto the stack. In postfix evaluation, we are pushing the operands onto the stack.